Let's take a look at the process of creating a partial fraction decomposition of a rational expression. A more familiar process that you may have seen before involves combining two rational expressions to create a single rational expression. So if I have two separate fractions that are added together or subtracted, we can create a common denominator and combine the rational expressions. The idea of a partial fraction decomposition is to start with the more complicated rational expression and rewrite it as the sum of simpler rational expressions. So I'd like to start with an example similar to this. First, we need to recognize the form that the partial fraction decomposition is going to take. And similar to the problem up above, we have two unique linear factors in the denominator, and so we're going to end up with two partial fractions. One of them has the x plus 2 factor in the denominator, the other has the x plus 3 factor in the denominator, in the same way that x minus 4 and x plus 5 each created their own partial fraction. And in the numerator there's just going to be a pair of constant numbers. So it'll be a over x plus 2 plus b over x plus 3. So our goal, what we need to do is figure out what the values of a and b should be. And we can do that by multiplying all the numerators by the common denominator, x plus 2 times x plus 3. So I want to multiply each of the numerators by that common denominator expression. So for this example, I'm going to actually write that all out. We have 7x plus 4 times x plus 2 times x plus 3, and that's all divided by x plus 2 times x plus 3. On the other side I have a times x plus 2 times x plus 3 divided by x plus 2 plus b times x plus 2 times x plus 3 divided by x plus 3. So there's going to be some cancellations, right? The whole point of multiplying by the least common denominator is to create cancellations with the denominator. So we can see on the left-hand side, x plus 2 and x plus 3 both cancel, and we're just left with 7x plus 4. In the a term, the x plus 2 cancels from the top and the bottom, and we're left with x plus 3. And for the b term, the x plus 3 cancels, and we're left with x plus 2. So we get the equation 7x plus 4 equals a times x plus 3 plus b times x plus 2. And the special thing that I want about this equation, I want this to be true all the time. And for that to happen, I need the coefficients of the two different terms over on the left-hand side to be equivalent to the coefficients on the right-hand side. In order for this to be true for all values of x, the coefficients have to match. So we can refer to this process as equating the coefficients. So let me simplify the expression, and then we'll see a little bit more carefully what that means. So I have 7x plus 4, and that's equal to ax plus 3 times a plus bx plus 2 times b. So rearranging things, gathering together the x terms, we see that on the right-hand side I have a plus b times x, if I gather those two together and factor out the x. And then what's left is going to be a constant amount, because there's no variable involved here. A and b represent constants. And so we get 7x plus 4 is equal to a plus b times x plus 3a plus 2b. And that means a plus b, the coefficient of x on the right-hand side, has to equal the coefficient of x on the left-hand side. So a plus b has to equal 7, and the constant part, 3a plus 2b, has to equal 4. So these two give us one equation, and the 4 and the constant part on the other side give us a second equation. So if we can solve that system of equations for a and b, it'll give us the values that we need for the partial fraction decomposition. So let's work to solve this system. The process we could use either substitution or the addition method for solving systems of equations. With the addition method, let me try to cancel out b, so I could multiply the top expression by -2, the top equation, I should say, by -2, and so I get -2a minus 2b equals -14, and I want to combine that with 3a plus 2b equals 4. And so if we add those together, we get just 1a, and the b cancels, and so I get 0b equals -10. So that gives me one value that I need. Simplifying this expression, we simply get that a equals -10. Plugging that back in, -10 plus b has to equal 7. So if I add 10 to both sides, I see that b has to equal 17. And so our final answer to the problem, the rational expression 7x plus 4 over x plus 2 times x plus 3 equals -10 divided by x plus 2 plus 17 divided by x plus 3. And this is a special relationship. This is an identity, not just an equation. This will be true for every possible value of x. We could check by combining these two fractions. So if I was worried that I made an arithmetic mistake along the way, we could check this by combining the two fractions into a single fraction with a common denominator. I hope you enjoyed the video. Thanks for watching.